Hi student friends, I am presenting my next video on the topic total differentiation. First of all, we try to discuss how we can find the total differentiation. If z is a function of xy, two independent variables, and x is function of variable t and y is also function of variable t, a function of function. Therefore, if we try to show this in terms of tree diagram, here z is a function of two variable x and y, and these x and y are function of variable t. Here function of two independent and xy are function of only one independent variable. Therefore, whenever we are finding the derivatives of z with respect to xy, that derivatives are partial derivatives, and when we differentiate with respect xy with respect to t, derivatives must be ordinary. Therefore, how we can obtain the derivative of z with respect to t? Here it is z. If you neglect this, z is a function of t, only one variable. Therefore, the derivative must be ordinary. It is dz by dt. Okay, it is dz by dt. Okay, and that is equals to z is not directly function of t, therefore we are not getting this value directly. How we to obtain this? Differentiate z first with respect to x and then x with respect to t. Okay, and therefore when we differentiate z with respect to x, it must be partial derivative. Therefore, it is dou z by dou x into chain rule. Derivative of x with respect to t, it is a function of only one variable. Therefore, it is dx by dt plus differentiate z with respect to y and then y with respect to t. Okay. Therefore, when we differentiate with respect to y, that derivative is a partial derivative, dou z by dou y, and y with respect to t, function of one variable. Therefore, it is dy by dt. Whatever this result we are getting is called as total derivative of z with respect to t. Okay, this is called as total derivative of z with respect to t. Okay, if we cancel this dt throughout, we have another form. We get total derivative of z dz as dou z by dou x into dx plus dou z by dou y into dy. Okay, we have the equation number 2. Okay, then sometimes we have like this: z is a function of x and y, and y is again function of x. Therefore, what is the tree diagram for this? Tree diagram must be like this: z is a function of two variable x and y, and this y is again a function of x. This is the tree diagram, and therefore we have to differentiate this with respect to x. It becomes and that derivative is the ordinary dz by dx is equals to differentiating first with respect to x and then x with respect to x. Its derivative with respect to x is a partial derivative, dou z by dou x, and derivative of x with respect to x is 1. Then differentiating z with respect to y and then y with respect to x. Therefore, it is dou z by dou y into dy by dx. Okay. Whatever this result, it is the total derivative of z with respect to x. Okay, and we have a fourth case. In case of implicit relation, general form is f of xy equals to 0. That type of function is said to be an implicit relation. For example, I will write x cube plus y cube minus 3axy is equals to 0. Two types of functions, explicit and implicit. This is an implicit. Implicit means we are not able to express y in terms of x as a function of x, or we are not able to express x in terms of y only. That type of relation is said to be an implicit relation, and its general form is f of xy equals to 0. Means if f is equals to 0 and f is nothing but z, if that function is equals to 0, its derivative is always 0. Therefore, if we use this equation 2, derivative of this function f means derivative of z is here 0, and the right hand side is dou z by dou x into dx plus dou z by dou y into dy, and then we try to rewrite it for dy by dx. Transferring this to other side, we get dou z by dou y into dy is equals to minus dou z by dou x into dx. And then rewriting it for dy by dx, it implies we get dy by dx is equals to minus dou z by dou x divided by dou z by dou y. Okay, and therefore we have it is equals to minus z means f. Therefore its derivative with respect to x I can write them as fx suffix x, and divided by derivative with respect to y, it is fy. Okay, therefore this is the result number 4 for total derivative. Therefore these are the 4 important results from total differentiation of total derivative. This is the total derivative of z with respect to t. This is the only total derivative, not with respect to x or with respect to y. Then this is the total derivative of z with respect to x, and this is the dy by dx whenever function is an implicit relation. Therefore we try to solve the problems of each type. If u is equals to u or z, whatever we can write, x raised to 4 into y cube and x is equals to t square and y equals to t cube. Question is find du by dt. Whenever ordinary derivative occurs in this chapter of partial differentiation, it is for this total differentiation only. That point must be total differentiation. And therefore, to find out this du by dt, we draw the tree diagram. Therefore, here u is a function of two variables x and y, and this x and y are function of variable t. And then we require to find this total derivative of u with respect to t, as I had discussed earlier while discussing that formulas. We get du by dt, ordinary derivative, that represents the total derivative here. By differentiating u with respect to x, and then chain rule, differentiating x with respect to t, then differentiating u with respect to y, okay, and then y with respect to t. Okay, then it is equals to four types of derivatives, four total derivatives we have to obtain. Differentiating u with respect to x, partial derivative of u with respect to x, keeping y constant. Therefore, derivative of this term is 4x cube, y constant as it is. Okay, dx by dt, differentiating this with respect to t, we get 2t. Differentiating u with respect to y, at this time x is considered as constant term, x is to 4 constant, derivative of y cube is 3y square, and derivative of y with respect to t, derivative of y with respect to t is 3t square. Okay, sorry, here it is y cube. Therefore, substituting the value of dou u by dou x, differentiating this with respect to x, we get 4x cube, y cube constant as it is. Dx by dt, differentiating this with respect to t, we get 2t. Then differentiating this with respect to y, x is to 4, derivative of y cube is 3y square, and differentiating y with respect to t, it is 3t square. Then substituting the values of xy in terms of t, it is 4 to the 8 t, x cube t square and its cube, y cube, y is t cube and its cube, plus 3 to the 9 t square, x is to 4, x is t square and it's raised to 4, and y square, it is t cube and its square. And therefore, if we simplify it, it is 8t raised to, add the power, this one is 9, 9 plus 3 to the 6, 9 plus 6 and plus this one, okay, and this one is 9, t raised to again 2, 4 to the 8 and 3 to the 6. Okay, therefore it is 8t raised to 10 plus 6, 16, and this one is 9 t raised to again 16. Therefore 9 plus 8, if you add this same power term, it is 17 t raised to 16. This is the required total derivative. Sometimes they may ask verify it. And therefore, to verify it, instead of applying this result or formula, we substitute that values in terms of t here, verification. Therefore, if you substitute that values, it becomes u is equals to x raised to 4, t square raised to 4, y cube, y is t cube, and its cube, and therefore it becomes t raised to 4 to the 8, and 6 is a 9, and therefore it becomes t raised to 9 plus 8, 17. Here u becomes a function of only one independent variable, and therefore the derivative of that with respect to t is ordinary. It is du by dt, differentiating it with respect to t, and therefore differentiating this right hand side with respect to t, it is 17 t raised to 17 minus 1, 16. If we call this equation 1 and equation 2. Therefore, if you observe these two values, equation 1 17 t raised to 16 and equation 2 17 t raised to 16, values are same. As values are same, a result is verified. Find partial differential coefficient of find partial differential coefficient of x square y with respect to x and with respect to y, with respect to x and with respect to y. That is the first part of the question. Second, and its total and its total derivative with respect to x when x and y are connected by the relation. That relation is x square plus xy plus y square is equals to 1. Two parts in this question. In the first part, we require to find partial derivatives of this with respect to xy, and in second part, its total derivative with respect to x. Therefore, let consider u as that given function x square y, which is a function of two independent variables. Therefore, if you try to draw the tree diagram, okay, and here we require the total derivative with respect to x. Therefore, y is a function of x, and therefore it is the formula third from that. What were the formulas I have discussed earlier? Therefore, when we differentiate this with respect to x, it is the total derivative of u with respect to x, ordinary type. Directly it is not possible. Therefore, how we are finding it? Differentiating u with respect to x and then x with respect to x. Derivative of x with respect to x is 1. Then differentiating u with respect to y and then y with respect to x. And derivative of y with respect to x, as it is a function of one variable, it must be ordinary, dy by dx. Okay. Therefore, here we require three types of term: partial derivative of u with respect to x, partial derivative of u with respect to y, and this dy by dx. And then we perform this differentiating u with respect to x. Therefore, its derivative is dou u by dou x is equals to keeping y constant, derivative of x square is 2x, and therefore it becomes 2xy. Okay. Then differentiating u with respect to y. This time x is considered as constant outside, and derivative of y with respect to y is 1, and therefore it is x square. Okay. I have obtained these two values. Then to obtain this third one, we take the help of this information. What is the given information? When x and y are connected by this relation, therefore that relation is x square plus xy plus y square is equals to 1. I will transfer to left, it becomes minus 1, therefore equals to 0, and we call this as function of xy. Therefore we get function of xy equals to 0, means it is an implicit relation, general form of an implicit relation. How it is an implicit relation? Here it is not possible for us to express x in terms of y or y in terms of x. That's why it is an implicit relation. And as it is an implicit relation, dy by dx is given by that result number 4, minus fx upon fy. Fx means partial derivative of f with respect to x. Therefore, I am differentiating this with respect to x, keeping y constant. Derivative of x is 2x. Derivative of this term with respect to x, it is y constant. Derivative of x is 1, therefore it is y into 1, that is y. These two are constant term, its derivative is 0. Then differentiating the same with respect to y, keeping x constant. Therefore, as it is constant, its derivative is 0. Differentiation of this with respect to y, x constant, derivative of y is 1. And differentiation of this y square, it is 2y, and derivative of this constant term is 0. Okay. Therefore, substitute this 1, 2, 3 in equation 1. Therefore, that equation 1 becomes okay. Therefore, what we have, dou u by dou x, it is equals to du by dx is equals to dou u by dou x. What is that value? 2xy plus dou u by dou y. What is value? X square. And dy by dx. What is the value of dy by dx? Minus in bracket 2x plus y divided by x plus 2y. Okay, and therefore this is the required result for du by dx. Multiplying it inside, we get its value as it is 2xy as it is. Multiplying here, it becomes minus x square into this, it is 2x cube. This into this, it is x square y, and whole divided by x plus 2y. Okay, this is the required total derivative of u with respect to x. This is the second type of problem. The third type of problem, if cos y raised to x is equals to sin x raised to y, then find dy by dx. Given cos y raised to x is equals to sin x raised to y. Here on both sides we have power term, and whenever power term is there, we can take log on both sides, or taking log on both sides. If you take log on both sides, log of this is equals to log of this. Then applying laws of logarithm, we get x into log of cos y, and that is equals to y into log of sin x. Then transferring this to other side, we get x log of cos y minus y log of sin x, and that is equals to 0, and we call this as function of xy. Function of xy equals to 0. It is an implicit relation. It is an and as it is an implicit relation, dy by dx is given by result number 4th, that is minus fx upon fy. It is equals to minus fx means partial derivative of f with respect to x, keeping y constant. Therefore, differentiating this with respect to x, keeping y constant, therefore this term is a constant term, log cos y. Derivative of x is 1. Then minus, here y is constant term outside, derivative of log 1 by sine, and chain rule, derivative of sine cos x. Okay. Then differentiating with respect to y, x is constant term, derivative of log 1 by cos y, and chain rule of this derivative of cos y is minus sin y, and minus derivative of this term, this time log sin x is constant term, okay, and derivative of y is 1. This is the result. Simplify it. Therefore, we get minus a log of cos y minus y, cos by sine we get cot x. This one is minus x sin by cos, we get tan y, and minus log of sin x. We can take minus sign outside, and therefore that become minus minus plus. In next step I can cancel this minus sign, therefore this minus, it become plus. This is the required result for dy by dx. Therefore, these are the three important types from total derivative. Try to solve some more of similar type for practice.